Hello students. So today we'll start one more point, that is programmable logic devices. In previous videos we have discussed about the SSI, MSI, ASICs. So in case of SSI or MSI ICs or in case of ASICs, they are designed for a particular function. Okay. So maybe say that is 74 series. Into that 74 series we have seen the different, that is 7447. So in previous example we have used, that is a decoder, 7 segment decoder. It is used for only particular that function. Okay. So likewise all the ICs will be designed for a particular function, but after that there will be improvement into the technology, and is it possible to build, is it possible to implement such a IC that will be programming at the user itself, and according to his design he will implement his own IC. So according to that, so manufacturer started the programmable logic devices. So programmable logic devices, PLDs, can be programmed after manufacturing to vary their function. Means PLDs can be used to design variety of functions, different functions. So that is not fixed for a particular function. So it will be designed for a general purpose and it will be programmed after manufacturing it. Okay, this is a programmable logic device. Okay, so it is designed for general purpose, and hence it will have higher cost than as that of ASICs. But in case of ASICs, it is designed for a particular function. It will have very minimum feature size, interconnections will be minimum, no extra devices will be there. Hence area will be small, density will be less, density will be more, and hence that will have low unit cost. But here it is in case of PLDs, it will have more area. It is designed for general purpose ICs, and it will have more extra ICs, more extra devices will be there. Okay, and hence area will be more, and hence unit cost will be more, but it will have lower non-recurring engineering cost. NRE cost is less. Okay, so it will be used for low to medium product volumes. That is, ideally it will be suitable for low to medium product volumes. Actually in 1970s, in 1970s, so manufacturer introduced a monolithic memory, okay, monolithic ICs, that is introduced by the monolithic memories. Okay, by using PLDs or programmable array logic, they have designed one IC, and that IC it is used for general purpose, and it will be widely used at the starting. Okay, programmed by the blowing fusible links in the circuit. So for that purpose, a particular for that purpose, a programming instrument will be used to blow the fuse. So what it is actually, we will take one example, PAL16L8. PAL16L8. So this programmable array logic 16L8, it will have 16 input pins, 8 output pins, actually low output pins. Okay, and out of that 16 input pins, 10 will be the input pins, only 10 will be the input pins, 2 will be the only output pins, and remaining 6 are served as a both input and output pins. Okay, now you can see here 16 input pins, out of that 10 are the only input pins and 6 are the output pins, input output pins. So 10 plus 6 will get the 16 input pins, and 2 plus 6 will get the 8 output pins. Okay, so there is another example of programmable array logic, that is PAL16R8. So in case of 16L8 there is no output register, and in case of 16R8 there is output register present, and hence we can use for sequential circuits. Okay, so we'll see the block diagram and what is the 16L8 IC. Now you can see here the structure of the 16L8. So here you can see these are the input output pins shown by the cross mark here. These are the input output pins. Now see here, so first is the, so this is only O1 output 1 and output 8, O1 and O8. So these are the particularly output pins. I1, I2, I3, I4, I5, I6, I7 up to here, I8, I9 and I10. These are only input pins. I1 to I10 are the only input pins. O1 and O8 are the only output pins. And now IO2 to IO7, these are the both input and output pins. These are both input and output pins. So now you can see here. See here, this is only input, this is only input, this is only input, this is only input. So all these are the input pins, and you can see here. So this is only output pin, this is only output pin. Now you can see here, this will perform as a output, also this will give as input. So these are the input output pins. Okay, now how to build any function. So let us take one example, that is here one sum of product equation is given here. Okay, product term equation is there, product term, then sum, and then OR will be there. Okay, so it is nothing but AND OR inversion, AND OR invert logic is there. Any function that can be implemented by using AND or invert logic. Here, that is, in case of vertical line and horizontal lines are there, whenever there is an interconnection, if the interconnection is present, then it will be shown by the cross mark, means interconnection is present here, that is fuse will be present here. And if the interconnection is not there, then fuse will be blown and there is a fuse absent there will be. Okay, now if you want to build this function, that how it is built, let us now see. So here there is interconnection is present here, this is interconnection is present on this horizontal line. How many are the interconnections? That are the only product terms. 1 and 2 are the only interconnections are there. They are the product term, product of this and this. What is the product? So this is nothing but the I2, and what is this? Nothing but I1. Okay, so I2, and here what is the input symbol? Here it is. So there is at the every input side there will be a buffer and inverter will be there. So this is symbol of input buffer as well as inverter will be there. Okay, so this two cross marks indicates one product term, I1 and I2. Okay, plus now this will be connected to AND gate, and then output of AND gate is connected to the OR gate. Now see here another OR gate, AND gate is there, another product term here it is. This, what is this? This is nothing but your I3. Okay, I3 here, it is not inverted form, it is non-inverted form. Okay, non-inverted I3 is there. Okay, I3. Then what is there on the horizontal line? Anybody interconnection is there? Anything? So here is the last is the interconnection. Now we can see the vertical line here, which is there. This is this is okay, and this is I10 bar it is. Okay, it is inverted, so I10 bar it is. Okay, so I10 bar, I3 dot I10 bar. This is one product term, and this I1 I2 or I3 I10 bar, it is connected to OR gate. So this is OR, and then it is inversion, so total inversion. So this function is there and it is given to the output. When it will be given to the output? When this tri-state buffer is activated, and this will be activated on this product term. What is the product term? Now we will see. So output will be enabled. Output will be enabled when these are the active. Okay, how it is calculated? What is the function for it? So you can see here it is. This is the I8, and what is this? I10 bar. Okay, this is the last I10 bar. So I8 dot I10 bar will be output enable equation for the output enable. In this way we can implement any function. Okay, so this is the implementation of this equation, and this equation enables the output. Okay, so this PAL16L8, it will have 16 input pins and 8 output pins. Out of that, 10 are the only input pins, 6 are the input output pins. Okay, and 2 are the only output pins, 6 are the input output pins. Okay, so this dotted line, this is the dotted line that will indicates the AND array. It indicates the AND array. Okay, so then next, what is contained into the 16R8? 16R8 is the used for the sequential functioning. Okay, so 16L8, it is used to implement functions, that is the combinational functions. 16L8 is used for circuits combinational functions. Okay, and 16R8, it is used to implement sequential functions. Sequential circuits can be implemented by using 16R8. As in case of sequential circuit, we require to temporarily store the data, so we require the registers, and also we require feedback. So that drawback into the previous circuit, that will be overcome in here 16R8. Okay, this is AND array, then OR, then here you will get the inversion. Okay, so that will be activated through a buffer. So this is D flip-flop is there, so D flip-flop will be activated. Okay, according to every clock pulse, that will be give the output. Okay, so this will be the Q will be the regular output, and here is the inverted output. Q bar will be the inverted output. Okay, so again here we require feedback, and that will be feedback. It is given for the from this Q bar pin, and this will be in two forms, that is in inverted or non-inverted form. So feedback path is useful for implementing finite state machines. Okay, so then designing with the PALs. So how to design with this PAL? So it is useful for implementing for the simple circuits. Okay, so this PALs are useful for implementing simple functions. It gives low cost solution. To implement variety of simple functions using single chip. By using single chip we can function. Okay, here we need to describe the function. Here we need to describe the function by using only Boolean equation, and that will be expressed in HDL. Okay, that is expressed in HDL language. Okay, then the synthesis tool transforms the equation into gate level circuit, which is verified by the test bench. Okay, finally the CAD design tool transform the gate level into fuse map. Okay, it will CAD design tool transforms the gate level into the fuse map, and the programming instrument, special programming instrument will be used, and that will converts which fuses to be blown. The function is too complex. If the function is more, if the function is large, then instead of using only one PAL, so we have to use more than one PAL ICs. To implement larger function, we have to use more than one programmable array logics. Okay, so then generic array logic, GAL. Okay, in PAL, programmable array logic, there are some facilities are absent. There are some facility are absent. That is like inverted output or normal output, registered output or normal output, feedback output, input output. Feedback input we require, and that will be every time it is not possible. So generic array logic, okay, PL, where is with the there is no output inverting, or there will be present, or the register output will be not there, output feedback is not there. Okay, in case of programmable output logic, micro cell is used. So this is in case of this OLMC, okay, output logic micro cell, OLMC. Okay, the generic array logic provides the output logic micro cell that replaces the combination of OR gate, registers and tri-state drivers in PAL output. Okay, so at here you can see here it is the combination of OLMC, output logic macro cell, OLMC output logic macro cell. It will contain OR gate, registers and tri-state driver. Okay, so it will contains all this OR gate, register and tri-state driver. So OLMC it is going to be represented, and remaining here the programmable AND array will be as it is. Programmable AND array is as it is. So input buffer or inverter will be present. Every input pin will be having inverted and non-inverted output. Now what is this OLMC? What is this OLMC? So this OLMC includes programmable multiplexers. They will having programmable multiplexers. The output OR gate is connected to the D flip-flop. Now you can see here output of OR gate, it is connected to D flip-flop. Okay, D flip-flop has asynchronous reset, synchronous preset. It will have inputs, that is the D input is there, clock is there, asynchronous reset pin is there, and synchronous preset pin is there. Asynchronous reset and synchronous preset pin is there. There are two multiplexers. This is one multiplexer 4:1 mux and another 2:1 mux. Okay, first 4:1 mux, it has four inputs. So see here, it will have 4 inputs. That is, directly you will get the output, inverted output you will get, registered output you will get, and inverted registered output you will get. Means direct output and registered output, inverted and non-inverting form will be there. By using select pins, we can select a particular output pin. Okay, and that will be again controlled by a output enable logic here. And another mux is there, 2:1 mux is there, and this 2:1 mux provides feedback for the sequential circuit. Okay, feedback for sequential circuit. Output driver in high impedance state provides direct input from the component pin. Okay, so output drivers are there, and it will be having drivers here, and that will be directly, any pin is not directly connected here. In some case of programmable, and that is in case of generic array logic it will having EPROMs. Okay, so all the, suppose one of the IC is there that will be designed for the particular function, then you can erase it by using ultraviolet rays, and once again you can reprogram it. So that is by using erasable programmable ROM, or electrical erasable programmable ROM will be there. Okay, so for example that is JL22V10, there is programming mux, OLMC, reset, preset. So all these facilities will be there with this generic array logic. Okay, then next we'll see about the complex programmable logic devices. It is, in short, it is called as a CPLDs, complex programmable logic devices. In short, it is a CPLDs. Okay, cramping multiple PALs into an one IC. Okay, now you can see here, in if we go for the further evaluation of the programmable array logic, it is caused advanced IC technologies to develop so-called complex programmable logic device. We can think CPLDs as interconnecting multiple PAL structures. It will have interconnecting multiple PAL structures. Okay, so there will be the PAL structures will be, this is PAL structure, this is PAL structure, PAL structure will be there, and interconnection between them. Each PAL consists of an array embedded microcells. So each PAL section, it will have embedded microcells as well as an AND array. Okay, it will have IO block. Okay, now each macro cell, now you can see here that each macro cell contains OR gate, multiplexer and flip-flop. Each macro cell, it will consist of OR gate, multiplexers and flip-flop. Okay, so PAL structure, it will consist of AND array, macro cell and IO block, and this macro cell consists of OR gate, mux, flip-flops. Okay, so it is used for the choice of the combinational function. So to implement the choice of the combinational or registered connection. Okay, so whatever you require, the registered input or output, inverted input or output. Okay, so that is combinational or registered connection with or without negation, initialization of flip-flop and so on. For that purpose microcells are used. There is no direct connection to the internal pins. From the output pins there is no direct connection. So there is a IO box is there, and through that IO box the connection will be provided. So this IO box is connected to the network box. Okay, so interconnection, the PAL structure allows us to use feedback connection from the PAL or from the external pins. So it will from the external pins, feedback connection will be from the interconnection network will be there. Okay, they uses SRAM cells to store configuration bit. So they uses SRAM cells to configure bit. Okay, so that configuration control can be done by using AND OR array and selects input and output multiplexers. This configuration data is stored in non-volatile RAM within CPLD chip. Within the CPLD chip there will be a SRAM cell. Okay, large CPLDs may contain 1000 number of gates and 100 number of flip-flops, which will allow us to implement even complex circuits. Okay, so now you can see here, so large number of functions can be implemented by using the complex programmable device. Okay, so this is about the CPLDs. Now today we will stop here for the today's video, and we will see. If you have any doubts, you can personally call me on the WhatsApp group.